Hello, my name's Spencer Roy.
Hello, my name is Mufaz Muhammad.
And I'm Josh Mashad.
So we are here with a three-link robot which we created for our demonstration of robot kinematics. We use different types of DH mounting over here. As you can see, we have a three-link robot with two revolute joints and one prismatic joint. We have a base frame on this board. We assigned all the required coordinate frames for this particular robot. By the assignment of these coordinate frames, we also got a DH table for this robot. And since this robot has three joints, therefore we have three rows over here. The first two rows represent the two revolute joints, and the third row represents a prismatic joint. And apart from that, there is a Arduino placed over here. We placed it smartly close to the base so that the reach envelope of our robot can be maximized. So this is the setup for our particular robot. Guys, we are done.
All right, then we'll start with the GUI of our project that we created using MATLab's App Designer. So first, we have this Generate Parameters tab, which we can use to generate the DH parameters of our robot and simulate the model. So we have a theta, alpha, A, D, and offset, and a button to choose revolute or prismatic. And then you could keep adding parameters, and once you're finished, you create a name and it writes a text file with the matrix of those DH parameters. And then we also have a transformation over here. This creates a transformation from the world frame to the base of our robot. So you can write the transformation here and it creates a transformation matrix once you put in a name for it, and it writes that to a text file as well.
So what you can do is then you can load those parameters just like this. And then you can create your robot. And then here you can see the base on the bottom right. And then you have, the base is at 0, 0. Then you have the first link, the second link, and the third link. And you can use these sliders to move it around. You can move the prismatic one as well, up and down. And these are set to our robot's limits, so this is exactly how our physical robot will move. And it also displays the distance from the base to the end effector, which is nice. And then what you can do is we have this optimized parameters section where you can enter in, you can record the joints and record a distance from the base to the end effector. On the actual robot, you can add them, it'll add them and save them, and then you can load them. And this will allow us to run an optimization to optimize our DH parameters and make the robot simulation more accurate. What it output was a bit strange, so here, let me see, DH, oops. Okay, so you have our optimized DH parameters and the base, and it optimized it in a weird way, so it must have found some strange solution, but it is more accurate than before. But this did run into some issues using the fmin search method. But other than that, everything works correctly.